Hello guys, in this video we are going to discuss the solution of the problem Toeplitz matrix. So let us look at the problem statement. A Toeplitz matrix is a matrix in which each descending diagonal from left to right is constant. That is, all elements in a diagonal are the same. Given a rectangular matrix mat, your task is to complete the function isToeplitz, which returns true if the matrix is Toeplitz, otherwise it returns false. So for instance, in the first example, if you see all the diagonals are same, so 6 6 6, and the diagonal which we are concerned of is left to right. So 6 6 6 is one diagonal which is same, 4 4 4 is another diagonal which is same, and then 1. Similarly 7 7 and 8. That is why this is a Toeplitz matrix, and because of which we are returning true. In the second example, if you see, the diagonals are not same. 1 and 5 are not equal, because of which it does not adhere to the properties of Toeplitz matrix, because of which we are returning false. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say the matrix which is given to us is this. So let us say this is the matrix which is given to us, and if we see the diagonal, so this diagonal has the same elements. Similarly, all the diagonals have the same element. Now let us go ahead and mark each of these diagonal. So let us say this is my middle diagonal, this is my upper diagonal number 1, and this is upper diagonal number 2. Similarly, this is my lower diagonal 1, and this is my lower diagonal 2. So first thing which we need to understand is, given a matrix of dimension n by m, what is the total number of diagonals? So let us answer this question. So the total number of diagonals will be equals to one middle diagonal plus the number of upper diagonals and the number of lower diagonals. Now let us see how many lower diagonals are possible. So remember, the matrix dimension is n by m, which simply means this is the number of rows we have and this is the number of columns we have. So if we have to compute the number of lower diagonals, then the number of lower diagonals is equals to the number of rows which we have, because each of these lower diagonals will start from the row itself. So because of which this will be equals to number of rows. So number of rows is n and minus 1. And the reason why I am deducting 1 from it is because of this diagonal, the middle diagonal, which we have already considered over here. So that is why n minus 1. Similarly, if we have to analyze and if we have to compute the total number of upper diagonals, then the total number of upper diagonals is equals to the number of columns, which is equals to m and minus 1. And this is minus 1 is because of the middle diagonal which we have already considered over here. So in this way, if you see, the total number of diagonals will be equals to 1 plus n plus m minus 2, which is equals to n plus m minus 1. But the important point to understand from here is the total number of lower diagonals is this and the total number of upper diagonal is this. So let me write it down. For a given matrix of dimension n by m, the total number of upper diagonal is m plus m minus 1. Similarly, the total number of lower diagonal is n minus 1 plus, in addition of these lower and upper diagonal, there is a middle diagonal. So this is the first thing which we wanted to understand. Now what we need to explore is, for each of these types of diagonal, how do we iterate on the diagonal? So let us take each diagonal type one at a time and see how we will be able to iterate on them. So for middle diagonal, it is pretty straightforward, which is, so if you see, this is the middle diagonal, and for this diagonal, the way we are going to iterate is I is equals to 0, and if we want to iterate on this diagonal, all we have to do is mat of I comma I. And in this way, and we will keep incrementing our I, and in this way we will be able to iterate all the elements of middle diagonal. So let us write it down. So for middle diagonal, we are going to set I equals to 0, and the way we will be able to iterate is essentially mat of I comma I. And once we have covered the first, and in order to move to the next element, all we have to do is we have to increase our I by 1. So that's about the middle diagonal, folks. Now let us discuss how we are going to iterate on the upper diagonal. So let us look at the upper diagonal case. So if you see in the upper diagonal, and let us look at this diagonal. So in the upper diagonal, the first element which we have is 0, 1. And then the next element which we have is this, which is at 1, 2. So if we assume that we are at an index I, j in the upper diagonal, then the next element of the upper diagonal will be given by I plus 1 and j plus 1. So let us write it down. So if we are at I, j, and what will be the starting position of I and j, we will discuss it. But if we are at I, j, then the next element will be at the position I plus 1 and j plus 1. So both the pointers needs to be increased by 1. Now let us see what is the starting position for I and j, or what is the starting value of I and j. So as we can see, the starting value is 0 and 1. I will be equals to 0 and j will start from 1. And once we have covered a particular diagonal, in order to move to the next diagonal, all we have to do is we have to start with I equals to 0 and j is equals to the next value, which is second value. Now since I is constant, then we don't really have to worry about I. We can always set I equals to 0. But how do we determine the value of j? Well, what we are going to do is we are going to express j in terms of diagonal number. So what we are going to do is we are going to say we will start our diagonal number with 2. The reason why we are starting with 2 is because the middle diagonal is something which we have already consumed, and the middle diagonal number was 1, because of which the next diagonal is 2. So that is why we are starting from diagonal number 2, and j will be equals to diagonal number minus 1. When we are at first upper diagonal, at that time the value of diagonal number is 2 and j will be equals to diagonal number of minus 1, which is equals to 1, which is this value, and I anyway is set to 0. When we have iterated on this diagonal and when we move to the next diagonal, then the value of diagonal number will increase by 1. So this becomes equals to 3. So the value of j will be equals to diagonal number minus 1, which is equals to 3 minus 1, which is equals to 2. So in this way, we will be able to initialize the value of I and j. And then once we have initialized the value of I and j, in order to move to the next element, all we have to do is this, which we are going to follow. And in this way, we will be able to iterate on all the diagonals, and all we have to check is essentially all the values are equal or not. If all the values of the diagonal are equal, then we are going to return true. Otherwise, we are going to return false. Similarly, for the lower diagonal, the same logic we will apply, and we will be able to initialize the value of I and j with respect to diagonal number, and with similar reasoning we will be able to conclude for lower diagonal as well. So that's the discussion regarding the solution, folks. Now let us discuss the pseudocode for this problem. So let us say we want to find out whether the matrix is Toeplitz and a matrix is given to us. So the first thing which we are going to do is we are going to check if the length of matrix is equals to 1. So if the matrix is of dimension 1 by n, then in that case it is a Toeplitz matrix and we are going to return true. Otherwise, let us operate on upper, lower and middle diagonal. So let us look at the middle diagonal first. So for middle diagonal, what we are going to do is we are going to have a value, and the initial value of value will be equals to none. And we will have another iterating counter with us, which is I equals to 0. So for middle diagonal, as we know, all we have to do is mat of I comma I, and we need to keep on increasing I by 1. So let us do that. So while I is less than minimum of len of matrix or len of matrix of 0. So what I am doing here is I am just computing the minimum of number of rows and number of columns, and that much is what I am going to iterate on. Now if mat I equals to 0, so that means it is the first value in the matrix, in which case we are going to initialize our value by matrix of I comma I. Otherwise, we are going to check whether value is equals to or not equals to mat of I comma I. If the value is not equals to mat of I comma I, then it is not a Toeplitz matrix, and in that case we are going to return false. Otherwise we are going to increase our ith pointer by 1. And in this way, from line number 4 to 9, we will be able to iterate on the middle diagonal, and accordingly we will be able to return false if it is not a Toeplitz matrix. Otherwise, now let us iterate on upper and lower diagonal. So first, let us iterate on the upper diagonal. So for upper diagonal, what we are going to do is we are going to have a diagonal number, and the diagonal number we are going to set it as 2. Now, while diagonal number, so remember from our discussion, the total number of upper diagonal will be equals to the number of columns. So this will be equals to less than or equals to length of matrix of 0. Now let us initialize the value of I and j. So for upper diagonals, the value of I will be constant, which is equals to j, and the value of j will be equals to diagonal number minus 1. And now let us iterate on I and j. So while I is less than length of matrix, the number of rows, and j is less than len of matrix of I, which is the number of columns. So while this is the case, and again value will be there, and the initial value of value will be equals to none. So if I is equals to 0, that simply means it is the first element of the diagonal, in which case we are going to initialize our value by mat of I comma j. Otherwise we are going to check whether value is not equals to mat of I comma j. If it is not equals to mat of I comma j, then we are going to return false. And for all the cases, let us increase our ith and jth pointer. So I will be equals to I plus 1, and j will be equals to j plus 1. And once this while loops end, this while loop, we are going to increase our diagonal number by 1, because we have to move to the next diagonal in the upper diagonal section. And in this way we will be able to cover our upper diagonal. Now let us look on the lower diagonal. So again, for lower diagonal, we are going to initialize our diagonal number equals to 2, and the total number of lower diagonals will be at most the number of rows, so that is equals to length of matrix. And now let us initialize our I and j. So here I will be equals to diagonal number minus 1, and j will be equals to 0. So for lower diagonal, I have not discussed it, but if you analyze with the same reasoning, you will come to a conclusion that j is equals to 0 and I is equals to diagonal number minus 1. So now let's proceed forward. So while I is less than length of matrix, j is less than length of matrix I. If this is the case, then let us iterate on the diagonal. So again, value will be there, and the initial value of value will be equals to none. If j is equals to 0, then in that case, let us initialize value. Value will be equals to mat of I comma j. Otherwise, if value is not equals to mat of I comma j, then in that case return false. And after doing so, let us increase our ith by 1 and jth by 1. And once the diagonal while loop ends, let us increase our diagonal number by 1. And let us say if lower diagonal, upper diagonal, and middle diagonal exhibits the property of Toeplitz matrix, then we are going to return true. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So the implementation is pretty much the same. So the first case is the base case, where the matrix is of dimension 1 by n. In that case, we can return true. Otherwise, we are checking the middle, lower, and upper diagonal. So this is the code for middle diagonal. If this holds, then we will move to the upper diagonal, which is this code, and then finally towards the lower diagonal. If at any times the Toeplitz condition is not met, in that case we are returning false, which is this, this, and this. And let us say if all the condition holds, then towards the end we are returning true. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.